Okay, as you've read, we are considering a 1D kinematics problem where a rock is thrown upward from ground level. All right, at 1.5 seconds, it passes the top of a tower. At 2.5 seconds, it reaches its maximum height. Our goal is to figure out what the height of the tower is. Okay, so the first step is always the one is what do we know? Well, we know one thing always in a vertical problem. Acceleration is negative 9.8. We also know 2 times. T max is 2.5 seconds, and T tower is 1.5 seconds. Okay? Now, because we have 2 times, we really need to do 2 different problems here. So we're going to separate it now. Problem 1, okay, is the max height problem. Okay. Problem 2 is the tower problem. Now let's look at what we know of each of those ones. Do we know the height of either of them? We don't. Question mark, question mark. Do we know the initial velocity of either of them? Again, the answer is no, we don't. Okay? Do we know V final for either of them? The answer is we know one of them. We know the final at the maximum height. At the maximum height, any object is going to have a 0 vertical velocity. So, V final equals 0, final equals question mark. And as we noted, we know acceleration is negative 9.8. And then we also have that time for the max height is 2.5 seconds. And time for the tower height is 1.5 seconds. Right? So, here we encounter our rule of 3. If you know 3 of any of these, you can find the other ones, always. Okay? Now, ultimately, we want to find this, the tower height, change in y. But sadly, we only know 2 values for the tower height problem. Not enough. We need to know a third. So where do we find that third? Okay? Well, one of the values is going to be the same between these 2 problems. Okay? Our height isn't going to be the same, obviously. It goes higher. Okay? And our final velocities aren't going to be the same. But we do know our initial velocities are going to be the same. Whether you're looking at it, whether your problem encompasses when it goes from thrown to when it reaches its maximum height or thrown and reaches tower height, either way, the initial velocity is going to be the same. That means we can find the initial velocity from the max height problem and apply it to the tower height problem. So, we want to find V initial. Okay, our equation that encompasses these 4 is V final equals V initial plus AT. Okay, V final 0. We have V initial minus 9.8 times 2.5. And we get that V initial is equal to 24.5. We can then take that and plug it in here. Okay? From there, we then can solve this problem. Now, our ultimate goal is to find this. So, we want to find the equation that has those 4 parts. The 3 parts we know and the part we want to find. In this case, it's change in y equals the initial t plus 1/2 at squared. Which in our case is going to be 24.5 times 1.5 plus 1/2 times 9.8 times 1.5 squared. And that's going to come out to be 47.775. And now, what does that value represent? It represents the height of our tower. Alright, Awesome.